Number 30, integral from 1 to infinity, 1 over x squared times ln x dx. This is improper because, well, first of all, this upper limit is infinite. That's clear to most people. However, you got to be careful. There's a domain restriction for this function as well. X cannot be 0. We're fine in that aspect because our limits don't include 0 or don't go through it. Okay? ln x, however, is 0 when x is equal to 1. Our lower limit's 1. So this is a double improper integral. We have to be careful, okay? And if you had just were or did not consider this lower limit as making it improper, you might get this wrong, okay? Because, okay, let's break it up first. We're going to break this up into 1 to e to infinity. I chose e because if I have to evaluate this integral, ln e makes the fundamental theorem of calculus portion nice. Or substitution, it will make the limits nicer as well. Okay, so what was I saying? So we split this up so that it's only improper on one of the two ends, not both ends, okay? And then we analyze from here. Both pieces need to converge for this original guy to converge. Okay, so as I was saying, I'm just going to say it right away. This piece, the one that people might miss, actually diverges. So this integral, original guy, diverges as well. This piece, even though I didn't evaluate it, let's pretend, I don't know, but let's pretend it converges. You totally missed that this one is the divergent piece, which makes this guy actually diverge. So you would have gotten it wrong, possibly. Okay, so we have to pay attention, especially when it's an improper integral. Okay. All right, so how do we show that this guy diverges, though, actually? This is the hard part. To do a direct comparison test. Okay, so this is how I thought through it. So on this interval from 1 to e, 1 over x squared ln x is greater than or equal to 1 over x squared minus 1. How in the world did I get that, though? Well, what is ln of 1? That's 0. What's ln of e? That's 1. So this natural log is increasing from 0 to 1, okay? So some number between 0 and 1 is being multiplied to x squared. Okay? That's number 1. And then number 2 over here, this is x squared minus 1. Okay? So, okay. And actually, I already forgot if I said this, but I was saying that this ln x would be some number between 0 and 1. So it's essentially making this x squared smaller. X squared times some number between 0 and 1. It's a fraction, so it's going to make it smaller, okay? Now, for versus over here, this is just x squared minus 1. This is just a constant minus 1 versus over here, as we get more and more close to 1, this will be more and more close to 0. And therefore, this product will be much smaller. So you can get the idea, hopefully, that this guy, since the bottom is smaller than this guy will be bigger. The final value after division will be bigger. Okay, this is not the most obvious comparison, so maybe you would need to take a few minutes on your own to actually think this through, okay? I'm going to leave that up to you, but this is a valid comparison here. You could probably choose a better function than this, but this is how I thought through it because I know how to evaluate this. When I'm making the comparisons, I'm also thinking, is this the function I'm using to compare it with an easy integral to evaluate? Because we can pick many, many functions that would satisfy some inequality like this. But if we are not able to evaluate the integral of this side, then what's the point of picking it? To show convergence, okay? So that's just a little trick or tip as you pick a function. You want it to be something you know how to integrate. So this I know how to integrate. This is partial fraction decomposition right over here, okay? And this is the antiderivative over there. I'm going to skip the steps. You can pause the video and go over that and try it for yourself. So the integral from 1 to infinity of 1 over x squared minus 1 dx, fundamental theorem of calculus, and take the limit, it's infinite. Therefore, this diverges. And since our guy's even bigger, our guys are going to diverge as well. So the original integral diverges since one of the two pieces diverge. So you got to be careful once again. You can't just focus on this one because this is the very clear limit that makes it improper. However, this lower limit also makes it improper and is probably the one this one in this case is the one that made it diverge. I'm not 100% sure this piece converges over here. I think it does. Yeah, I'm pretty sure it does because by the comparison test and all that. This piece will converge, but this piece diverges. So the actual answer is it diverges. If you just focused on this piece, you'll say it converges and you got the answer wrong.